My name is Dr. David Raju. I am from Computer Science and Engineering Department. Today let us discuss one course. That course name is Big Data Analytics. Now let us discuss some more elaborated ways of this Big Data Analytics. In this Big Data Analytics, we will going to discuss about what is this. Prior to that one, I want to talk about introduction. In this introduction part, let us discuss how this big data comes into action. Prior to go for this big data analytics, let us discuss about how this huge data comes into the world. With the advantage of the new technologies, many more new inventions are happening throughout the world. Many inventions. With these many inventions, we can see latest electronic gadgets we can see throughout the world. These electronic devices that are occurring due to the advent of the new technologies, this can capable of carrying very huge information or huge data. How? Let us go for that one. Let us take a simple example of mobile device. That is, in earlier days, in my mobile device, I used to store only 256 MB information. That means just go back to 10 years back or 15 years back or something like that. And after that one, we can see 256 plus 256 almost 512. It is 512 MB. After that one, we have seen some of the things 512 plus 512, that is 1024. This MBs we can call it as 1 GB. We are seeing this kind of devices in our days. Further, this 1 GB now translated to, I am talking about the hard disk. This now it is around 256 GB, and also it goes to 512 GB, and some of the devices may touch to 1 terabyte also. These are the things that's happening at most of the locations or most of the devices. Now I'm talking about this hard disk. At present, the hard disk carries almost 1 terabyte or something like that. Now this is in terms of actually computers. If you come to the 1 terabyte, now almost for mobile devices, it touching 256, 512. That's sophisticated mobile devices. Now, if you come to this RAM that is there in the systems, of course, now it is almost 8 GB RAMs. It is running in the market for the systems. Yes, this technology improving rapidly, new inventions are happening, new electronic devices are occurring in the world. Now, with the advantage of the new technologies, very huge information I am keeping inside these devices. Now, just I gave here some one mobile device or CPU. Suppose if you go for other things, basically this huge data will be saved in very huge servers that are located at various agencies. That is, take Facebook and then Twitter and then Google, Yahoo. These kind of agencies, they are carrying these huge servers. Now, prior to go for this, what is terabytes, gigabytes, and all those things, I want to talk about how this memory space hierarchy looks like. I am talking about the memory space hierarchy now. Memory space, how this improving day by day. Now, let us see 1000, that means 1024 kilobytes, we can call it as 1 gigabyte. Suppose 1024, I am writing it as 10 cube. 10 cube, sorry, this is megabyte. 10 cube megabytes, this implies 1 gigabyte. That means I can write it as 10 cube into 10 cube. Here, let us talk about here kilobyte. I am starting a megabyte. If you go further, I can call it as 1024 bytes. 1024 bytes equal to 1 kilobyte. These 1024 kilobytes I can call it as 1 megabyte. 10 to the power of 3, that means 1024 megabytes I can call it as 1 gigabyte. Here at this juncture, if you want to write in terms of only bytes, I can write like this: 10 to the power of 3, 10 to the power of 3, 10 to the power, that is 10 cube, 10 to the power of 9. I can write simple terms, I can write these things like this. I can write like this: 1 kilobyte equal to 10 to the power of 3 bytes. 1 megabyte, that is equal to 10 to the power of 6 bytes. 1 gigabyte, I can write it as 10 to the power of 9 bytes. If you go to 1 after this gigabyte, then terabyte, what we are looking at the systems now. This is 10 to the power of 12 bytes. That is equal to 10 cube gigabytes. That means 1024 gigabytes. After this terabytes, we will go for petabytes. Petabytes 10 to the power of 15 bytes. After this petabytes, we can go for 1 hexabytes. Hexabyte 10 to the power of 18 bytes. After this one, hexa, tera, peta, hexa, and then if you come to zettabytes, it is 10 to the power of 21 bytes. These are the hierarchy. Now I want to explain about this kind of information, how it is storing in different kinds of environments. Now I am coming back to one important live scenario that talks about this huge data. Just I am coming back to the real scenario, how this huge data is stored at different locations. I am taking New York Stock Exchange. If you take New York Stock Exchange, almost it saves, New York Stock Exchange, it saves almost 4 terabytes of data per day. 4 terabytes of data per day. If you come to another example, if you take Facebook, prior to go for this Facebook, I want to talk about the general scenario, how we are utilizing the space in day-to-day life. Let us talk about, if you take one selfie photo, it occupies a space of 2 MB. Just you assume you are taking at an average 5 photos per day. That means you are utilizing 5 into 2, that is equal to 10 megabytes per day. You assume that your friends or your classmates, almost 120 members into 10 MB. You can go for the college, almost 2000 approximately, into 10 MB. If you go for other colleges, if you go for West Godavari, then AP, then India, then the world, almost if you accumulate all these things, for the Facebook I am talking about, it is 240 billion photos. 240 billion photos that we are saving per month. It carries around 7 petabytes of data. 7 petabytes of data per month. That means these photos require 7 petabytes of data per month that is accumulated in the Facebook servers. If you go further, that is ancestry.com is there. Ancestry.com. This is another website that talks about the genealogy of the human race. This almost carries again 14 point something petabytes of data. If you go for another thing, that is Internet Archives, what we are looking at here, Internet Archives, this will carries that's around 17 petabytes of data. And then if you go further, Hadron Collider is there. Hadron Collider. This is the purely nuclear physics collider, which is located in Geneva, Switzerland. in Geneva, that is located at Switzerland. That is a huge collider that's circumference is almost 24 kilometer circumference, huge collider that is dig just below 100 meters of from the earth space. That means it is a very huge circle, what we can say, tunnel will be there. Tunnel was there, is there now. This tunnel circumference is 24 kilometers. It carries a tunnel. In this tunnel, this is just below 100 meters below this earth surface. This tunnel carries one huge accelerator beams will be going on for every second. Huge accelerated electrons, protons, those things will be rotated along this huge collider. In this collider, there are almost 7 or 8 detectors are there to detect what are the elements that are emanating from that collider surfaces. That carries almost per year, this is 4 zettabytes of data almost per year. 4 zettabytes of data per year. All these things why I am saying is, this huge data we have to save in some location. That locations in general we can call it as servers. This huge data we can call it as big data. This data what I am saying, that is the big data. Now I am coming to big data and its definition. This big data I already told you. Now I am talking about this big data. Yes, so far we have seen how this memory space will looks like. This is the statics. We should know prior to go for this big data. Now all this big data, whenever we are talking, it talks about tera, peta, hexa, and then zettabytes of data. This is exabytes, exabytes and zettabytes. Now from this point onwards, we can call it as huge data or big data. Now let us come to this big data. Big data is a huge data. Big data is a collection of large number of data sets. Collection of large number of data sets. Large number of data sets, which can't be processed. Which can't be processed. Which can't be processed. Which can't be processed by traditional computing devices. Cannot be, that is important. Can be processed by traditional computing devices. Traditional computing devices. Traditional computing devices. That we have to remember. So, yes, this huge data that we can't store, here we can keep one more thing, which can't be stored or processed. Stored or processed. By using these traditional computing devices. We can't do these things. That kind of data we can call it as the big data. This big data, already I told you how this big data is accumulating in Facebook. I have shown you some of the examples, that's all. We can see several examples. Suppose if you take the sensor data, atmospheric data, that contains lot of log information that stores for every 5 seconds or 7 seconds or something like that. Now I talked about the introductory part, how this huge data comes into action, how this memory space looks like, and then what is this big data. Now let us go to some of the examples where it is located. Let us take Facebook servers and then Google servers. We can take WhatsApp servers. All these things carries lot of information. Stock servers, stock market servers, they have their own dedicated servers with them. At different countries carries different servers. Now in this big data analytics, we talk about this huge data storing, at the same time this huge data analysis that carried in from next session onwards. Prior to go for that next sessions, we will see how this big data, what this big data characteristics, that means characteristics of this big data, how we can say those characteristics. These characteristics basically contains 3 V's. This big data characteristics having these 3 characters, 3 V's. One V is it has huge volume of data. Big data is huge volume of data. It has volume which has some high velocity of data accumulating in this big data servers. At the same time, large extent of variety of data. Large extent of variety of data. You see, these three V's, the data which contains these three V's, we can call it as the huge data. Huge volume is nothing but, I said already, how this huge volume data is accumulating among these different servers, that we are initiating. As the human beings, we are doing some experiments or we are collecting data. All those things that is saved at some huge servers, that we can call it as the huge volume capacity servers. And then high velocity. That means if you take the internet clicks and advertisement clicks, all those things in microseconds, it will capture the user information. All the data will be stored in these servers. At the same time, different variety of data will be stored in these servers. What are the different variety? Just I am coming back here. What is variety? This variety of data may be structured data, or semi-structured data, or unstructured data. Now I am coming back to semi-structured, unstructured data. Just I am erasing this point. Just this huge data, this I am keeping it here. This structured data is nothing but ordinary relational database data. Ordinary relational database data. That means the tables what we can see. This kind of data, serial number, name, something like that, that kind of data we can call it structured data. It has some specific structure. That means table, columns, it has some, this is integer type, this is the string type or something like that will be there. Another one is semi-structured data. How this semi-structured data looks like? If you take any XML file that it describes sometimes UML diagrams, that describes sometimes the programming codes, sometimes it describes the front-end coding. This kind of XML files we can call it semi-structured data. Let us take, this looks like something property, and then it has some configuration, and then it has some name, and then something like this. Again, configuration, property, something it looks like this. This kind of data we can call it as semi-structured data. This is one example for semi-structured data. This is another example for the structured data. Another one is unstructured data. This unstructured data has no proper structure. Let us take one log file, how I am entering into the website, the website total clickings and my timing and other how much space I am utilized, all that kind of comes out as log data. If you take sensor data also looks like log data. Log data means if you take some sensor data, it looks like this. 1201908031246, something like this. Some of the first letters indicates the latitude, longitude, then the other thing indicates the year, other thing indicates the month, this is the day, this is the time, or something like this. This kind of data we can call as log data. Or examples of this unstructured data, we can video files and audio files. All these things comes in images data. All this data comes under this unstructured data. So I hope you understand what is this big data. I am coming back once again. In my introduction of this big data concept, I talked about how this big data comes into action, how the technology advanced. According to the technology, how this new electronic devices comes into action, electronic devices. From this one, how this memory space improved, accordingly how information is stored in different locations. We have seen this kind of things. This information extended up to zettabytes. And then we talked about how this memory space is there. I talked about this memory spaces, and then how this huge data stored in different locations. I gave several examples. That is New York Stock Exchange. So far we have discussed how this huge data comes into action. For saying that kind of things, I told how this huge data comes into action through this advent of the new technologies, from the invention of this new high volume memory, and then how this information is stored at different locations. After this one, I talked about this memory space, how it is tangible, and how we can see this kind of memory locations throughout the world at various devices or various servers. From that one, we have seen the live examples of storing of this huge data by saying this New York Stock Exchange, Ancestry.com, and then Hadron Collider, that kind of things. After this one, I came to I discussed about this big data and this definition. This definition is nothing but a collection of large number of data sets that can't be processed by using the that can't be stored or processed by using the traditional hardware devices or computing devices. Suppose for this big data examples, we can take Facebook, Google, WhatsApp, stock market, this kind of agencies. They can store this huge data in their individual or own servers. And then big data characteristics, we discussed those three characteristics. We have seen huge volume, high velocity, and a large extent variety of data that is stored in this huge data. These are the characteristics of the huge data. Whatever the data you take, that data contains these three kinds of characteristics. That data which contains these characteristics, we can call it as the big data. And again, this variety of data, we can say structured, semi-structured, and unstructured data. I explained what is structured data, what is semi-structured data, what is unstructured data. Thank you so much. We will discuss the other things later in the next session. Thank you.